Hi everyone, we are discussing non-rigid transformations today. Okay, so now we're going to talk about how to actually change the shape that we're dealing with. Alright, so first thing we're going to talk about, we send a text message with this emoticon and we get a reply, but our reply looks really distorted compared to the original one. Okay, so what transformation occurred to make our emoticon so distorted? Well, it looks like this is a horizontal stretch. Okay, so like the integrity of the shape is now totally different. Hey, this is not a dilation. I guess you could consider this a dilation in one dimension, whereas vertically we did not change. Hey, but this is not anything to scale. Hey, my shape has fundamentally changed. I've changed from a circle now to an ellipse or an oval. Okay, so we can change the size of a figure in the coordinate plane by multiplying the x and y coordinates by different factors. Okay, where a dilation, we multiplied everything by the same factor. And now if we multiply the x and y coordinates by different factors, we can stretch or compress. Right, so what we can see here is a stretch will increase the distance and a compression will decrease the distance. A horizontal stretch is where we just stretch laterally, and a vertical stretch is where we stretch up and down. Okay, we want our factor here, our scale factor, to be greater than 1 for a stretch and between 0 and 1 for a compression. Okay, that's the idea here. It's the exact same thing as function transformations. Okay, so let's do our first example. We have a quadrilateral EFGH with vertices given, and they want to know the coordinates of the vertices after we transform to 3x and 2y. Okay, so what this tells us to do is multiply all of our x values by 3 and all our y values by 2. Okay, super simple. So I'm given, we started at -2, I'm going to multiply that by 3. So I get -6, I get 6, 6, and -6. Okay, I'm going to multiply all my y values by 2. So I get 4, 4, -4, -4. Okay, so if I graph my new shape, I'm at -6, +4, -6, -4, 6, 4, 6, -4, and I have stretched out what used to be a square into a very large rectangle. Let's try that again. Okay, I've stretched out my square into a rectangle. Alright, that's the idea. Next, they're asking, how's the transformation xy to 2x 3y different from 3x 2y? So as you can see here, instead of a scale factor of 2, I have a scale factor of 3 in the lateral direction, and a scale factor of 3 here, and a scale factor of 2 here in the vertical direction. So that's how these transformations would be different. This transformation here would turn, for instance, a square into a taller rectangle, whereas my transformation here would turn a square into an oblong rectangle, okay, or longer rectangle, I suppose. Alright, next example, we have a triangle, STW, so that's our big triangle here, and our compressed triangle, I should say, because it's much smaller. We can see that, S prime T prime W prime. They're asking if this is a vertical compression or a vertical stretch. This is definitely a compression. Okay, and they want us to write a coordinate rule that maps our larger triangle to our smaller triangle. Okay, so the idea here is I'm going to take any new point, okay, and divide by my old. That's the idea. So I see that I used to be at 4 right here. Let's use here. Okay, so I used to be at 4, now I'm at 1. Okay, I used to be at 4, now I'm at 1. So I'm going to take my new point, okay, now I am at 1, divide by my old point, and that is the scale factor that we used. And that will apply for any of these points. Let's use another one just to make sure. So I used to be at -1, now I'm at -4. So same idea there. Or if I check S, then I used to be at -1, now I'm at 4, so the exact same thing. Okay, so my scale factor is 1/4, so if I write my rule, I've gone from xy to x 1/4 y. Okay, that's the idea. Okay, now they want us to write a coordinate rule describing a vertical stretch factor of 2. So vertical stretch meaning y, so I need my y to have a 2 next to it. So this is a horizontal compression by 2, I suppose you could say. This is a vertical compression, horizontal stretch by 2, and this is my vertical stretch by a factor of 2. Alright, moving on. We have a triangle, ABC, and the given vertices. And they want us to find a new image after a dilation of scale factor 2 centered at the origin, and then a horizontal stretch, just in the x direction by a factor of 2. Yeah, that's the idea here. So they gave me my vertices, so we can go ahead and calculate our new vertices after dilation. I'm just going to multiply everything by 2 because that's what they told me to do. So I have -4, -4, 0, 2, 0, -4. Okay, and then I'm doing a horizontal stretch by a factor of 2, so only my x values will be affected here. So I'll have -8, -4, 0, 2, 0, -4. Alright, so let's give this a graph. So just my dilation, I'll do my dilation in blue. Just my dilation, I am at -4, -4, so this is my value for A. I'm at 0, 2 for B, and then I am at 0, -4 for C. So here is my triangle after a dilation of scale factor 2. And now after that I stretch this, so now I'm at -8, -4, so nothing has changed vertically, only laterally. This is a double. And then because nothing's changing vertically and I'm already at 0, B and C do not change. Okay, so now, well, let's try that one more time. Now I am right here. Right, that's my new triangle. Okay, so then they're asking me, how can you determine the coordinates of the pre-image if we know the image's coordinates after a dilation and then a horizontal stretch? That's the idea. Okay, so note that we did the horizontal stretch first, and then we did the dilation first, and then we did the horizontal stretch. So we're gonna have to go backwards. Okay, so we would do the horizontal stretch first, and then we would deal with the dilation. Okay, we need to do the opposite, so since we stretched, we need to divide or multiply by the reciprocal, and because we dilated, I guess, positively, I guess it doesn't matter, you'd multiply by the reciprocal or divide by your scale factor. So I would need to multiply by the reciprocal of the scale factor of the stretch, and then multiply by the reciprocal of the scale factor of the original dilation. So your answer would be C. Okay, moving on. So we have the vertices of my triangle, and this is our image. Okay, I can tell because of the double tick marks. So they want me to find the pre-image coordinates, and they told me that we had a dilation with scale factor 1/3 centered at 0, -1, and then a compression. Okay, so I would need to deal with the compression first, and then I would need to deal with the dilation. I think it's easiest to see this graphed. So let's go ahead and deal with this dilation. Sorry, deal with the compression. So I would need to do the opposite of a compression by 1/2, so I'm going to multiply by 2. Okay, and it's just to my x value. So I'll have -2, -1, 0, 1, and then 2, -1. Okay. Then in terms of my dilation, because we're not centered at the origin, can be a little bit tricky, so let's go ahead and just look at what this looks like on the graph. Okay, so this is my image. Now after the dilation, if I plot those points, I'll end up here, here, and here. Okay. Alright, so that's after my dilation. Now after my horizontal stretch, I keep saying that. After my horizontal stretch. So now if I think about where my pre-image is, hey, this is after a dilation of scale factor 1/3. So now I would need to think about dilating by a scale factor of 3. So let's take a look at what that would be. Again, we're going to multiply everything by 3, okay, and we are centered at 0, -1. Okay, so we're centered right here, and we're going to multiply everything by a factor of 3. So 2 becomes 6. Okay, -2 becomes -6. So this is P and this is R respectively. And then Q will increase by, again, a factor of 3 from this point here. Okay, so that's kind of the tricky part. My distance was 2 from my center of dilation. Now my distance needs to be 6. Okay, so this distance is 2. Now I need to multiply that by 3 and get that distance to 6. So I'm going to end up all the way up here. And this is my image. This is my original image of PQR. Alright, so we can go ahead and jot down the coordinates of my pre-image. So P is at -6, -1. Q was at 5, 0, and then R is at 6, -1. Alright, that is it for these notes. Your homework is below right here, that worksheet, so if you have any questions, let me know. Otherwise, have a fantastic rest of your day.